In this case, let's go over how to set up full arch zirconium cases. In order to have better shape around your anterior cases or gum area for your full arch cases with built-in gum, then it'll be definitely better if you use C-clamp. So let me show you what the C-clamp is. It'll basically have an open fixture, so you're able to tilt the machine to a greater angle, so your gum area can be milled out better. But sometimes if you have a terrible angle of your one of the implants too, then we can have those angles on the open fixture areas. So in this case, let's select 25 millimeter. Typically, most of full arches, we tend to use 25 millimeter. And we definitely use MMT because it has a greater strength with the aesthetic. So definitely, I recommend getting a MMT if you're buying a zirconia from 3DBioCAD. Let's go ahead and select load parts. I'll go over some of the other type of restoration too, but let me just show you uh, just the typical day-to-day full arch cases that you guys might run into. In order to have full arch cases, I would highly recommend you have a very good computer just for calculation reasons and just moving the STL file here and there. If you have a very good CPU as well as graphics card, then you will have a better experience. And in this case, the system will say 24 millimeter. You can see here. Okay, and it's selected as abutment crown bridge. I mentioned about 3SM file from 3Shape and construction info file from ExoCAD. Those file will let you know what kind of type you're doing it. So make sure we have them and select abutment crown bridge. So I'm gonna just click and open the file. Okay, so double click on the crown and let's rotate, and you'll be able to bring this little forward. And as you can see, I want to show you something. As you can see, there's a outer boundary and inner boundary. So you can bring it to all the way out to inner boundary. If you go over more, then what happens is, uh, if you look at your zirconia puck, there's a shoulder, and that shoulder will actually make this anterior area cut out. So you don't want to bring this too close. You want to just bring it up to where the inner line circle is. Okay, then you're perfect. In this case, you always want to look at if there is angle cases or if everything is just a straight channel. Especially for PowerBall, and if you're doing angle channels, then this setup will be your very first step, but you have to do second step in order to accomplish getting those angle channel areas. How do you know any of them are angled? If you look at the channels, you will have one arrow if it's a one straight channel, but you will see two arrows if for angle channels. Also, you can go to identify power features and go to implant interface. Then it'll show you here there's a number. This number represents you have 6 channels. So you have to count and see if you actually have 6. So Here's 1, 2, 3, 4, 5, 6, and you have 6. Sometimes if you have 7 or 8, you might want to delete those 7 and 8. There's a uh, integration problem. Sometimes that's happening from ExoCAD and 3Shape with a hyperDENT. So just to make sure you want to check, you have right number of channels and not right number of selection from the hyperDENT. So if you actually click here, select next screw channel, or from the keyboard, you can go next. So it'll get highlighted as yellow. So that's 1. And then I have 2, I have 3, 4. And if there's any angle channels, then you'll have here selected as it is angled. So from this full arch case, it's all straight channels, and it'll actually be pretty easy. So first, what I usually do is I get rid of this fixture and hide select it, and look from the front view. Then I can see how this bridge looks angled. Okay, so if you're using a multi-layer, then this is not the greatest setup that you can have. You probably want to tilt and make it a little bit more aligned from the anterior side to posterior side. So I'm going to select tilt part in blank, and here you could enter manually. I want to show you how it does. So let's enter 5, click minimize. Okay, so it tilted a little bit. And let's try 15. Yeah, so now looking at it, it looks a lot better. But whenever you're making this tilting, you also have to check your angles of the screw channel, because if you tilt it too much, then the machine might not be able to access your screw channels. So let's take a look at the angles of the screw channel. But after tilting it, you can double click again and bring the mouse to the top of this sphere, and you can click and hold left button from the mouse, and you can go up and down. Okay. You don't want to bring it too much up. You just want to slide uh, at the little bit more than probably center. Okay, so go to top view, and I want to look at, usually this is just like the surgery too. If I can see channels at a minimal angles, then I'm fine. But if you want to know detail angulation, how much machine can mill, you can actually zoom in and tilt it and bring the mouse to the arrow of the channel, then it'll show you the angle. So in this angle, as you can see, look at the bottom z-axis, then it's at 24.9 degrees. So if it's within 30 degrees, then this is fine. Also, typically, anterior regions tends to have a shorter screw axis, but you need to look at the posterior area and bring the mouse, then it'll actually show you the diameter and length of the screw channel. So if you bring it again, and it has an occlusal of 9.64 millimeter. So you have to consider how tall your 2 millimeter burr is. 2 millimeter burr being used for a PowerBall is 20 millimeter. So you can actually be able to mill channels that are 20 millimeter long. So you can check ahead of time and see if it's okay. All right. So in this case, everything looks fine. So that was with the inspection and just general setup. So now let's put the screws. Okay, so I'm gonna click manual. Typically, I put about 6 to 7, just to have a good support of the channel. If the bridge is bigger, then you could put actually 8 screws. So typically, I have 6 on the lingual area and 2 on facial side. Okay. I'm just trying to minimize adding a connectors on the facial side just for you to have less time uh, carving at the green stage. All right. And then after you have all the connectors, then we have to put the stabilizer. So make sure you have a stabilizer. Stabilizer is needed in order for your zirconium to shrink proportionally. Without the stabilizer, if you're trying to bake your just a full art zirconium cases, it might have a dispersion, and as a result, you might not have a passive fitting, or it might have some issues. But make sure when you have the stabilizer, make sure you center. It's depending on your furnace, but you want to center for about minimum 12 hours. If you try to center faster, then what's going to happen is you might have a micro uh, fracture from where the connectors are, and which you don't want it. So from our experience, from our laboratory experience, we were getting much better success. Uh, we were getting much better success after centering for about 13 hours. Okay. After that, go ahead and select undercut area for from the bottom right, and it'll show you where the undercuts are. So you can see all the interproximals have undercuts. So how do I get the best result? So in order to get the best results, we're using something called user defined. Basically, the concept of the user defined is users are defining the area where you want to have the machine to mill. So all these area where you're getting undercuts, go to identify part features again. And typically I put it on the top view. Okay. And here under parameters type, select user defined areas. Okay. So in here, it'll ask you to draw contour. Okay. So click on here. Okay. But if you're having a V9 or above, then you're able to do this a little bit faster. You can just go straight and click on the draw user defined areas. Okay. So on here, what I'm going to do is I like to select span by yourself and then smooth curve. All right. So basically what I do is from the top view, okay, I'm tilting a little bit. So when you're looking at this view, this gum areas will come out, will be milled fine. But then, see like here, anterior regions, it's not going to. So what I typically do is I tilt and see now you can see the gum area better. So I'm going to select here and here and here, form triangle, then bring the dots and bring down to inside your edges The reason why I do that is my whole idea is to mill gum area. So you don't have to do much at the green stage. Okay, so we'll bring this down. Okay, and then click accept. Okay, you want to do the same for this area. So one, and it can the user defined can overlap each other too. So a lot of people ask me if it is okay to overlap them, and that's totally fine. Again, my whole idea is to try to get this gum area. But the reason why I'm having a bigger user define is by milling the whole surface, it'll it'll have more uniform shape of the whole surface. So it's actually going to look better too. And then from the occlusal to slightly rotate. But drawing a user define on the posterior area, we have obstacle. And obstacle is this fixture. So I cannot draw bigger user define like how we were identifying open space area. So I'm going to have a less bigger user define, meaning a little bit closer to the actual surface. And I'm trying to still angle these gums, right? So I just bring it like this. But see, like this one, I want to go like this. Yeah. The reason why I'm having this curve is basically I don't want to spend more time and milling the whole, like the occlusal side of it. So that's why I'm just doing all the zigzag for anterior side. So this one, I don't want to bring it like this because if I do that, then the angle will be so much greater that the machine will try to hit the fixture. So I need to bring it very close. And then click accept. So typically I draw about 4 user defines, 2 on the anteriors and 2 on the posteriors. Okay. Sometimes if the posteriors don't really need user define, you don't have to do it. I just want to show you how to do it. So see, like here too, I'm looking at here, like here. So this is okay. So basically we are defining this circle for machine to mill extra. So we can actually mill those gum area better. Okay. After that, go back to identify part features. So now we have 16. So what this 16 selection means is we have 6 pink lines, meaning abutment base. So 1, 2, 3, 4, 5, 6, and then uh, we have another 6 emergence profile. So green represents emergence profile. So 6 pink and 6 green. So that's total of 12. And then we have 4 user defined. That's why we have total of 16. Okay. So let's check the angle. So right now it's at angle of 7.6 degrees. I can tilt a little bit more. A little bit more. Okay, so 9. Okay, let's try 9. So one thing it is really good with the hyperDENT is I can manually set the angle whatever I want. So I have a flexibility. So 21. So the angle of anterior can be at under 60 degrees. So you can have a bigger angle. Bigger angle means the machines will mill at this angle, this viewing angle that we have. Meaning we'll definitely have a better shape like this. You don't want to have more than 60 degrees because this fixture might be hitting the ceiling of the machine fixture. So you just want to be careful. Okay. So after setting all the angles, we want to know if the boundary is fine. So here, it's very close from this fixture and very close from fixture. So as long as it's not touching, you're good. And if you double click, see if you go slightly, then it will say milling boundary not within fixture boundary. So you just want to make sure it's not touching. Okay. All right. So before you start the calculation, make sure you want to select Jonathan PowerBall. So regular template is for tie-based cases. So if you're doing tie-based, all the restorations, then you don't have to select different library. But if you're doing PowerBall screws, then you want to select JA PowerBall. Okay, and just click accept and close it. After you select the PowerBall template, then make sure you check here and it's actually showing PowerBall, because a lot of times they think that they selected PowerBall, but they have a tie-base template. So if you select the tie-base template, what happens is the sitting area of the screw axis will be milled out. So the screw will just go all the way through. Well, make sure you check you have selected JA PowerBall, looking at under template here, and make sure you save the project just in case if something happens and you want to start the calculation. And during the calculation, if you see massive, very weird error messages, you want to terminate the hyperDENT, open the project again, and start the calculation. Or you might have to restart the computer and start the calculation. Then you'll have the best, and then you'll be able to successfully calculate and start the milling job. I want to show you another thing about user defined, because when the machine is milling at this angle, see, you can see the whole circle right. So machine is able to, when machine is milling user defined, machine needs to fully see the boundary. But sometimes people draw like this, and let's say I'm not able to see the boundary of here, then the machine will error out. So make sure when you're doing it, the hyperDENT is able to see the whole line of it. Just like here too, if I'm angling at this degree, this angle, then I have to be able to, computer needs to be able to see the whole circle in order to mill, because that's the machine's boundary. Okay, same as here too. So you don't wanna draw user define like from the exactly facial view, because if you draw from the facial view and look from the little bit angle, then you're not able to see the whole circle. If the machine is able to see the whole circle, you're fine. But if not, then it'll have an error. Make sure whether you're able to see the user-defined circles clearly or not. Okay, then this is very successful, so you're okay. And from the next video, I want to show you for angle channel and some other tips and tricks. Please watch the other hyperDENT training videos. Thank you.